Hi, welcome back again in the series of the video psychometric chart. In this video, I will shortly explain what is outdoor design condition and indoor design condition for someone who doesn't know, for the beginners, because it is very important to understand these two terminologies and what is the concept to understand the psychometric chart and plotting the condition on the psychometric chart in order to calculate the total cooling load. So what is outdoor design conditions? Outdoor design conditions. And what is indoor design conditions? Indoor design conditions. As its name is indicate, outdoor design condition is the condition of the air or properties of the air outside your building. As it indicate, indoor design condition is meaning is that as its name indicate, indoor design condition or indoor air properties of your building. This is called, they mention as a design over here, design over here. So as per standard, we have as per the standard which says there is indoor design condition must be 22 degrees centigrade and 50% relative humidity. So how we achieve these two values is that ASHRAE is American body for heating, refrigeration, air conditioning, set a standard for human comfort. Human comfort. So what is human comfort? Human comfort means the conditions where the human feel comfortable. Human comfort conditions. The complete term is human comfort conditions. So human comfort condition means this is the conditions. If we can able to reach this condition, the temperature of the air is 22 degrees centigrade and relative humidity 50%. It means that we are able to provide human comfort condition. Then human comfort condition is a very important concept, very important point we need to provide inside the room. So this is the building, for example, room or building, and this is where we need to provide 22 degrees centigrade and 50% relative humidity by using any air conditioning device through air. But the air we will take from the outside condition, outside area. So this value, as I said, 22 and 50 is a constant. It is not going to be changed any part of the world. It may be slightly variation will be there, 21 or 22 or 24, depending upon the culture and the social norms, but the outside conditions are variable. So this condition completely depends on country and regions. So ASHRAE again tabulated all the values for different regions and different part of the world. For example, if I'm going to take an example here, let me take another file, another clear file, so I can explain you clearly. So for example, the Middle Eastern region, if I say, or let's say if I say the Australian region, Australia, and in Australia we have various cities. Let's say we can take Perth. The condition for the outside design condition for the Perth is dry bulb temperature is equal to 40.5 degrees centigrade and wet bulb temperature is 24.5 degrees centigrade. Same if I took another region, let's say Middle Eastern. Again, in Middle Eastern, there are many cities, many countries. For example, here I will take Qatar as a country and Doha as a city, where dry bulb temperature is, outside dry bulb temperature is almost equal to 47 degrees centigrade and wet bulb temperature is around 32 degrees centigrade. So what it means that if you want to provide cooling, if you want to provide air conditioning in the region Perth, you have to change this condition, or you have to cool this air from this condition to this condition. Dry bulb equal to 21 degrees centigrade and wet bulb equal to relative humidity will be equal to 50%. Same way In the Qatar also, you need to reach this condition. So clearly you can see in these two examples that this is the first condition for both the region, and this is the desired condition, the second condition we need to achieve. Okay, now if you see the difference from 47 to 21 degrees centigrade, here from 40 to 21, it means that the cooling load required for this two region will not be the same. So the cooling load, a cooling capacity required in the region like Doha, Middle Eastern region, is more, but the place like Australian place like Perth will be less for given same volume of air. For example, if I'm taking 5,000 cubic feet per minute volume of air, the cooling capacity will be different for these two regions or any other region. It will not be same for any other regions. So this is the major difference depending upon the outside and inside design condition. These are the same condition, these two conditions we will plot in psychometric chart. You can see in my list of video, you can find, and I just completed the video on how to plot this condition for the city Perth. So you can see in that video how we can plot this condition. In the next video I will explain. For example, I almost forgot that these conditions you can get. You might have a question from where I got these values. This condition you can get the ASHRAE tabulated values directory. You can see on my screen. This is the value for Perth I took, 40.5 and 24.1. If you want to know how to read this chart also, I can make a separate video on that as per your request. But as of now, if you see here, you need to just find a value. For example, I will show you an example. Like I will go to let's say in India, and I will select any city, random city, let's say New Delhi. Now in the New Delhi the conditions are 44 and 29. So for the New Delhi, again we can take an example. I can write over here for the New Delhi is 44 approximately, and think 30. Let me check again. Yeah, 29.8, approximately 30 degrees centigrade. So again, from this condition to this condition I have to reach. So this is what the difference between indoor and outdoor. So in conclusion, all these values are outdoor conditions, outdoors ODC, and this value is the IDC, indoor design condition. This will be the constant, it will not be changed, and this is as per ASHRAE standard definition, comfort condition, human comfort condition, where the human being feel comfortable. And this is where these are the values or varies depending upon the region to region, as I explained you. In next video, you will see further more details, how to plot this condition and how to calculate, by doing so, how to calculate the cooling load for this different region, for the different, to reach the different values by using the same formula. Till then, bye, and just keep on watch for further videos. Thank you very much.